All right, let's take a look at this problem here. So it took Priya 5 minutes to fill a cooler with 8 gallons of water from a faucet that was flowing at a steady rate. Let W be the number of gallons of water in the cooler after T minutes. Okay, so I'm just gonna put your information down. I suggest you get into the habit of underlining, highlighting important information. So for me, it's gonna be 8 gallons of water, 8 gallons of water, and that's gonna take 5 minutes to fill up, 5 minutes, okay? And W be the gallons of water. Once again, this seems like important. W be the gallons of water and T minutes. So W represents gallons. W represents gallons. And T represents minutes. Okay. So let's take a look. It seems like they made this into a decimal. So let's try. I'm going to divide 8 divided by 5 and see what we get. 8 divided by 5. Okay, so 8 divided by is 1.6. So it is 1.6. So what this means is this. So if I get 8 divided by 5, and I divided it, and I got 1.6, right? And this used to be gallons, and this is minutes, right? But now there's no fraction, right? There's no fraction here. So then how do we see this 1.6? Well, actually, we can see this 1.6 as 1.6 over 1. Because any fraction or any whole number can be made into a fraction by putting an over 1. So it's going to be 1.6 gallons over 5 minutes. Or you could say it like this. You could just say 1.6 gallons per minute. So every minute, right, it's being filled up by 1.6, a faucet, yeah, a cooler. So it's filling up a cooler, 1.6. So what makes sense is this, right? If you take a look, so if we have W is equal to, we're taking a look at this problem right here now. So what this means is, like, let's just say I put in, so this represents time, and this represents water, right? So let's just say I put in 2, right? It took 2 minutes, right? If it passed 2 minutes, then let's take a look. 1.6 times 2, it should be 3.2, right? So let's take a look. 1.6 gallons, 1 minute, right? And we do 2 minutes, right? So it's going to be 2 minutes, and 1.6 times 2, 1.6 times 2 is 3.2. So in 2 minutes, 3.2 gallons would have been filled. But if you take a look, it's the same thing. 1.6 times 2, 3.2. And this water, this W represents 3.2. So therefore, W is equal to 3.2, which means gallons, remember this is gallons, gallons have the number of gallons of water is 3.2 after 2 minutes has passed. 2 minutes has passed. So this works, right? So this works, but let's take a look at this one. Does this work? I'm not sure, okay? And the reason why is 0.625. And I think the way that they got that is from this here. I'm gonna move this a little bit. Gonna resize, make it a little smaller, move it over here. So we're gonna get this again, right? The only thing is, I think they made it a reciprocal, right? They made it a reciprocal. So they did 5 minutes over 8 gallons. So let's do 5 over 8 gallons. So 5 over 8. 5 over 8. And then you get 0.625. Once again, 0.625 can be made into a decimal like this per 1 gallon. So in order to fill up a gallon, it took 0.625 minutes. So now this one, right? Let's take a look. if I put in 1 minute, right? So let's do W is equal to 0.625 times T, right? If I put in 1 minute, right? If I put in 1 minute, the gallon should be 1 gallon, right? Okay, or actually if I put in 6.25 for T, I should get 1 gallon, right? Because the reason why is because after 0.625 minutes, 1 gallon has been filled. That is the constant proportionality that we're given. Okay, but let's put in 0.625 here into this equation, and let's see if we actually get 1 gallon or not. Okay, and I think already you can see that it's not. So we've got 0.625 times T, right, is 0.625, 0.625. And then W is equal to 0.625 times 0.625, 0.625 times 0.625. And we get this crazy number, 0.390, 0.390625. 0.390625. And that definitely does not equal to 1 gallon, right? 1 gallon. So this equation does not work, right? So B actually does not work, right? Because when we put in 1 gallon into this equation, or 0.625 into this equation, it does not give us 1 gallon. However, I'm going to show you guys another example here. Okay, I'm going to actually make this smaller. Resize. Oh, I like this resize thing. It's really nice. Is this one right here. Let's try this one. So once again, we said that 5 minutes is 8 gallons, as we said right there. And then that is equal to 0.625 for time, minutes, over 1 gallon. And then that's what we got that from there, right? And so now what I'm going to do is I'm going to do actually T is equal to 0.625 W, right? And then now this water represents gallons, right? So 1 gallon. So let's put in W, let's put in 1 gallon. And if I get 0.625 as time, then this equation works. So I'm going to put in 1 gallon here. I'm going to put in 1 gallon right there. So it's going to be T is equal to 0.0625 and 1 gallon, right? That is, in fact, equal to just 0.625, right? See, I put in 1 gallon, right? And then what did I get? 0.625, which, by the way, for T, which is my minutes, I did get, in fact, 0.625. So this equation works. So this equation works, right? And this equation works. That equation works. But as you will see, if we do the same thing, that actually will not work. And I'm not going to go into that details because this video is going to be getting long. So let's take a look. So 1.6. So what does 1.6 tell me? 1.6, like we said right here, tells me how many gallons per minute. So 1.6 represents the number of gallons per minute. Okay, 6.25. That's crazy. 6.25 represents the number of minutes per 1 gallon, right? They're reciprocals of one another. So Priya changed the rate at which the water flowed through the faucet. Write an equation that represents the relationship of W and T when it takes 3 minutes to fill the cooler with 1 gallon of water. So I just want you guys to see this. Depending on, so remember, every constant proportionality can be written as a reciprocal of each other, right? So we got this reciprocal is that reciprocal. 8/5 is the same thing as 5/8. It just, every constant proportionality could be written in that form. And because of that, there are two different equations that can be written. W is equal to 1.6 T and T is equal to 0.625 W. But the only thing that you have to notice is that this T and this W, you see this T and W, they're switched. This T and W is switched. So if you want water, right, we have to use 1.6. If you want gallons, you have to use 1.6 T. And then if you want to get minutes, you have to put 0.625 gallons. Okay, it's a little confusing. This is the first lesson on it, so it is going to make more sense as we move forward. But I want you guys to keep that in mind because that is pretty important. So let's take a look at this one, right? So we're gonna do 1 gallon of water, right? I'm gonna do 1 gallon. By the way, I want you guys to pause the video and try this yourself. Now that you have some understanding of this lesson. So we're going to write an equation, right? So it's going to be, I'm going to do 1 gallon of water, 1 gallon of water per 3 minutes. And the reciprocal is that 3 minutes takes 1 gallon, right? So it takes 3 minutes. Yeah. So I'm going to talk about this one a little bit. I'm going to make this a little bit easier. This is the same thing as 1/3, right? Gallons per minute. I want you guys to know that. I just got this 1/3, put 1/3 here, and put gallons over minute like that. So this is another important information that you have to realize is that what this basically means, 1 gallon over 3 minutes, is the same thing as doing 1/3 of a gallon per minute. Okay, let me see if I can show you guys that. So let's just say I have a container, and then that is 1 whole container, right? There's 1 whole container, and that takes 3 minutes to fill up, right? To fill up. Then how much will it fill up? Will it take to fill up after 1 minute, right? And this is 1 gallon, right? 1 gallon. So it takes 3 minutes to fill up this entire thing, but then in 1 minute, then if I have this thing, after 1 minute, if it takes 3 minutes to take up 1 gallon, and after 1 minute, it's gonna do 1/3, right? It's only gonna fill up 1/3 of gallon in 1 minute. Okay, I hope you guys see that intuition behind that. I know the drawing is pretty horrible, but if it takes 3 minutes to fill up the whole thing, right? 1 gallon, in 1 minute, it's gonna take up 1/3 of a gallon. Okay. Anyways, let's keep going. So this one represents my gallons over minute, right? So this represents my gallons over minute, and this equation did that as well. So what we're gonna do is we're gonna write W is equal to 1/3 T. And for this one, we're gonna write T is equal to 3 W. Okay. Now I'll show you guys later. If you guys want to check it, just put in this number. See, if I put in 1 gallon for water, 3 times 1 is 3, right? So my T is gonna be 3. So just kind of get used to it for now. We'll practice it more in the next problem. So was the cooler filling faster before or after Priya changed the rate of water flow? Explain how you know. Well, let's take a look. So we got 1/3 gallons per minute. 1/3 gallons per minute before. Gallons per minute. And then this one was 8/5 gallons. 8/5 gallons, 5 minute. Remember, this is the same thing also as 8/5 gallons per minute. Okay, same thing. Okay. So, obviously this is going to be more, right? And the reason why is because this is 1.6. 8/5, like we said, is actually 1.6. So this is taking 1.6 gallons per minute. Gallons per minute. And this is only taking about, if I do 1 divided by 3, 1 divided by 3, that's going to be 0.3333. That only takes about 0.33 gallons per minute. So this one, the first one was definitely filling a lot cooler, faster than the second one. So I hope that helped, and I'll see you guys in the next video. Bye.